So usually solve this problem is by having a pose-normalized representation. So that if, for example, for a cube, we unfold it to a pose-normalized view, a canonical view, and then we extract features. And there has been multiple works that uses this idea. For example, Deepface from Facebook has applied this idea to faces, face identification. It has been applied to categorizing birds, and also applied to categorizing cars. So these are all objects that have similar shape, but the differences are very subtle, and you have to look at the appearance of the object. So the goal of this talk is to show that this post-normalization representation is not optimal, and also to introduce two alternative representations, post-retargeting and post-synthesis, and show how to apply that for the problem of cuboid categorization, and also show that these alternative approaches can show state-of-the-art results. So what is the problem with post-normalization? There are two main challenges. One is that they usually require very accurate 2D landmarks, and the other one is that post-normalization representation usually incurs some image distortion. So, for example, in the first and second row, you can see a very highly distorted normalized view of the object, because we see the object from a very specific view. And in the third row, you can see if our pose estimation is wrong, the pose normalized representation would be wrong as well. So an alternative representation we have shown is pose retargeting. So the basic idea is that instead of warping the test image to a canonical pose, we warp all of our trained set to the pose of the test image. So here the test image is on the left, and then you can see all the training images are warped, and then we extract features and do whatever we want to do on these features. And still this is suffering from inaccurate pose as test type, which I will show that shows us post-synthesis is a better strategy. So post-synthesis means that instead of transforming any training or testing images, we just augment our train set with some new generated images. For example, cubes, we can get the texture of the cube and render it from various views. So these are some samples of synthesized cubes from different views, given the 2D image on the left. So in synopsis, given a query image and a train set, for a pose agnostic, we don't do anything. We just extract features from the original images. Pose normalized, we transform everything to a canonical view. In pose retargeting, we keep the test image intact, and we warp all of our training data. And post synthesis, we augment our training data. So we have done extensive experiments using various classifiers and features, and we have shown that categorization accuracy for post synthesis is better than other approaches. And so we have done some analysis. You can see our data set has 9 categories of cubes, and I guess I'll leave the discussion for the poster session.